I would like to tell the traceability, how important it is to the industry. Probably most of you, they will be using one or the other type of instruments in their entire shop floor area. It could be a very simple vernier or a micrometer or a dial gauge. And all these instruments, it seems to be very simple, but the results they can produce on the end product, it is a very tricky task. So traceability plays a very important role in all these instruments. Why? Because today we are having exposure. Many of the companies are more into the export of these components, or maybe some assemblies, or even OEMs, or their tier 2 and tier 3 suppliers also are involved in the production industry. So we are just discussing about how important is this traceability. So as I was telling you, the traceability chart, it goes right from the SI units, which are derived units from which all our other standards are derived. So basically, SI units, from there, the premier institutions like the National Physical Laboratories, or the UCAS, or DKD, or METAS, or any part of the globe you travel, there is a National Metrology Institute which preserve these primary standards. So today I would like to discuss with you little in detail about these length standards. So basically, when I talk about length in India, meter is considered as the length standard, for which National Physical Laboratories in New Delhi, they have maintained the primary standard for this. So from there, what all are the other secondary standards are there, we are just trying to get them calibrated from NPL, so that the traceability chain continues. From the secondary standards, all other standards from the calibration laboratories, maybe it is a third party calibration or in-house calibration, all the calibration will take place, and it's a uninterrupted chain of calibration traceability, which makes it very critical when it comes to the final product. So it could be any industry for that matter. Today we are having so many opportunities in India in the aerospace industry, medical engineering, as well as in the electronic industry. So Mahr, we are not left behind. We are also very much prepared to support the industry, so that even the small scale industries and MSMEs, as well as the high end OEMs and the corporates, they are ready with the solutions. So when I talk about these standards, the secondary standards, of course, the slip gauges are the secondary standards which we are maintaining. We normally call them as the zero grade slip gauges. So through zero grade slip gauges, we are able to measure many instruments like vernier, it could be micrometer, or it could be dial gauge also. So when I talk about all these things, how important are all these things in the aspects? When we are talking about exporting, of course, in the automotive industry, today we have this IATF 164949, which is very critical for the industry. They have to qualify in this area. They have to maintain so many instruments, the calibration certificates, their set of records, everything. It is nowadays it is coming into the digitization world also. So to support this, the Indian government, in association with a Quality Council of India, they have developed a team. It's a national NABL. This is the company who certifies the accreditation of all the calibration laboratories, whether it can be mechanical calibration, whether it can be electronics, it can be electrical, pressure, pneumatic, any company for that matter. It is the certifying agency who certifies this. They will conduct an audit and they will certify the calibration laboratories, and they will give this NABL 17025 accreditation for the laboratories, certifying that this laboratory complies to the quality and other standards which are relevant in the industry. So when it comes to defense sector, of course, we have this DGQA and the DGCA, which are very critical in these areas. where they have their own set of standards and they have their own set of protocols, which are decision making authorities. So when this total traceability, it looks to be a very simple task, but you just imagine maybe a vernier or a micrometer, it is not calibrated or it is having some error. So this can definitely give the end product unexpected results. So it seems to be a very simple mechanism, but unless until this chain of calibration is not maintained, unless until we have a good traceability of all the masters which is maintained in any laboratory or any quality assurance department, then the end product, the result could be very much challenging and it can go to the stage of rejection also. So to support with Mahr India, we have come up with a beautiful instrument. This is a part of the automation. It is called a Presimar I100 IP. I hope you are able to see in the image. This is a full automatic dial gauge calibration tester, wherein we are doing full automatic calibration of the instrument without any involvement of any man intervention is required in this. So we can keep the dial indicator in this setup, and we have to run the pre-program in this machine, and it can check all the different parameters what is needs to be certified for a dial indicator according to different standards. If you take a GIS standard, in this case, we can refer to a GIS standard called GIS B7503 or a DIN standard DIN 878. So we can pre-program this machine to 266 different programs, and it can certify automatically the instrument by running through different steps, whether it can be a whole measurement range error, it can be 1/10 of the error, it can be half revolution, it can be repeatability, and all these tests which are very much critical for a dial gauge to comply whether it is working properly or not. Those tests can be performed, and it is a part of this calibration this machine can do in full automatic mode, and no human intervention is required in this machine. So when I say human intervention, if it is a digital dial gauge, we understand that digits can be traced. If it's a manual analog dial indicator, then there is always a chance that the instrument can induce a parallax error because of the human intervention. And in this case, that is also ruled out because we have a high resolution camera which can take the images, and it can give a very high quality image on the screen, and full automatic measurement takes place without any human intervention. So this is a part of the automation what Mahr is trying to give to the industry, so that the man hour is reduced. If a manual calibration takes place, it requires around 20 to 22 minutes for a dial indicator for a full calibration to be completed. Whereas in this case, we can complete the cycle in less than 3 minutes. That means you are able to save almost 60 to 70% of the human idle time, which could otherwise be utilized in a better way, and the overall operational cost or the calibration cost of these instruments can be considerably brought down. So as I told you, the focus adjustment, the whole setup is done with a very high resolution camera, and because of that, no human intervention is required, and it is totally automatic, and it can do a full automatic calibration. So this is one part of the automation what Mahr is trying to support the industry. Apart from this, as I told you, traceability also plays a very important role in this case. Why? Because traceability at the end, it will give a tremendous output for the results whatever the instrument is going to give. That is totally depend on all the previous calibrations, whether it could be a secondary master, it could be a working standard, or the instrument itself. So the total overall maintenance, including the calibration, it plays a very vital role in this case.